Hi, in this video, we will learn how to perform the inverse Laplace transform by using the table. When you perform the Laplace transform, you convert from time domain signal into Laplace domain signal. And if you perform the inverse Laplace transform, the process is just inverse from the Laplace domain to time domain. So you can use the L to indicate Laplace transform, L inversion to indicate the inverse Laplace transform. In general, you can perform two steps to get the inverse Laplace transform result. First step, present the Laplace transform result fx in the partial fraction decomposition format. So this is the partial fraction decomposition format that you have learned. And then step 2, refer to the table for the suitable transformation. So with that, you can convert fx into the ft, time signal. Let's try with this example. So by refer to the table, you can find that this format is similar to this formula. This is similar to this because you have x squared plus a constant. Last one, you have x squared plus 4, which is similar to these two. And you have x and a constant component, which is these two as well. So we can use this table to perform the inverse Laplace transform. To obtain h power 5, refer to this, your n should be equal to 4. So at the top here, you get 4 factorial, and when you convert to time domain, you get time power of n, which is 4. With that, you obtain 4 factorial divided by x power 5, and the inversion of this, you get t power of 4. And don't forget, multiply with 1 over 4 factorial so that it can be cancelled to get back the equation that you want to solve. In example B, you have x squared plus 7. When you compare, omega squared will be equal to 7 and omega is square root 7. Then you get the inverse Laplace transform, and when you convert, you get sine square root 7t. So don't forget, multiply with this constant, because when you cancel, you get back the original equation. So your answer should multiply with 1 over square root 7. You have x squared plus 4 in C, and then when compare the 4 to the omega square, you get omega equal to 2. For the negative 2x over the denominator, we can refer to formula 9, and for the constant 6 divided by x squared plus 4, we can refer to the formula 8. By using the formula 9 and 8, you can find the inverse Laplace transform for these two terms to be cos 2t and sin 2t. And the tricky part will be, you need to use the constant so that when you multiply, you get back the original constant that you want. So you have to multiply with a suitable constant here. And this one, you have negative 2x. Constant you can take out. Most of the time you have the Laplace transform result fx in this format, and you have to perform the partial fraction decomposition to get more simple term to be solved. So you can see that you have linear factor x, linear factor x plus 1, and this is repeated linear factor x plus 2, that's why you repeat 2 times, and then a, b, c, d is the unknown constant. You have learned the partial fraction previously, so I will skip the step here. You should be able to obtain the result like this. So your a is 1, b is negative 14, c is 22, lastly d is 13. When we compare to the table, you find the one similar to the format. So the x here, 1 over x, is same with the formula 1. X plus 1 here is same with the formula 5. X plus 2 square is same with the formula 6. And lastly, x plus 2 is same with the formula 5. So we can use 1, 5, 6 formula to solve this. So 1 over x, you directly can get the answer 1. So when you compare x plus 1 with the x minus a, you get the a equal to negative 1. So substitute inside this, you get exponential negative t. So this is the answer. And x plus 2 here, your a will be equal to negative 2. So substitute inside, you get exponential negative 2t. Last one, x plus 2 compared to x minus a. So your a will be equal to negative 2. So substitute inside, you get te negative 2t. So this is the answer. Let's find the inverse Laplace transform for this. So first step, you need to perform the partial fraction to get the decomposition. So you can see you have one linear factor and this is quadratic factor. So linear factor you have unknown constant a, and for quadratic factor you have first order polynomial here, where the b and c are the unknown constant. So by perform the procedure of the partial fraction, you can obtain the unknown constant a to be 1, unknown constant b to be negative 1, and lastly c to be 0. So this is your answer. So 1 over x, we can use the formula 1 to get ft equal to 1. X over x squared plus omega squared, we can get cos omega t. So with that you obtain this answer, where you multiply 1 over x with 1 over omega squared. So 1 over x, when you inversion, you get 1. Then you have negative 1 over omega squared multiplied with the x over x squared plus omega squared. So the second term, when you take the inversion, you get cos omega t and multiply with your constant here. So this is your final answer. Similar method can be used to solve the second problem. So in this case, you have quadratic factor x squared and quadratic factor x squared plus omega squared here. So at the top, you have first order polynomial where a, b, c, d are the unknown constant. You can also treat the x squared as the repeated linear factor. So if you treat it as repeated linear factor, you have a over x plus b over x squared. So you found that you get the same answer here. By perform the partial fraction, then you get the final answer, where your a, b, c, d is this answer. 1 over x squared can be converted to time domain by using the formula 3, where you get ft equal to t. 1 over x squared plus omega squared, you can find from the formula 8, where you can see there is omega at the top. So with that, you have to divide omega at the bottom so that you get back the original problem. So omega at the bottom here, you can multiply inside to get omega power of 3. So with that, you can obtain this term. When you convert to time, you get sine omega t. 1 over x squared, you get t. So the other constant remains here. So this is the final answer. You might have more than one method to solve the same problem. So let's say this is the problem that you have solved previously. And you can see both problems have this term. And by referring to the formula 8, you can find that there is missing omega at the top. So if you multiply omega at the top, you should divide omega at the bottom. When you perform the inversion of this term, then it will become sine omega t. So multiply with 1 over omega. So this will be the answer for this. So you can see that for the fx equal to 1 over x squared plus omega squared, so this first problem is like fx divided by x. And the second problem is like fx divided by x squared. So with that, we can use the formula 22. Okay, so if you have divide in x domain, it will be integration in time domain. So to solve the first problem here, so you have the fx divided x for this term. So by refer to the formula 22, so you have the integration for the f tau. So f tau can be obtained from your original ft function. So t and tau are dummy variables, means that you can replace t and tau to be any symbol. So they are just dummy variables which can be replaced by any symbol. So when you replace the t to be tau, then t here should be replaced by tau here. Therefore, you obtain this result. So substitute your f tau inside here, and then you integrate, you get negative cos omega t divided by omega. So omega multiply omega at the bottom, you get omega squared. When apply the limit, t substitute to the tau inside, you get cos omega t divided by omega squared. Then you get this term. And substitute the 0 inside, cos 0, you obtain 1 divided by the omega squared. So your ft is equal to this answer. So when you have the fx equal to this. So when you divide the fx by x, then this one becomes x squared. So with that, it's the same with the second problem here. And you can use the formula 22, okay, when you divide by x here, like this one, then in your time domain, you should be integrate with respect to time. So on your left hand side here, it is fx divided by x. So on your right hand side here, it will be integration. So this is your f tau. So tau is the dummy variable with the time. So you have ft equal to this. So if you just replace the t with tau, so you can replace the t with tau here. So just substitute this term inside here. This is your f tau. So then you perform the integration. So 1 integrate, you get tau. Cos integrate, you get sine omega t divided by omega. And substitute the limit inside, then you should get the final answer. So in this example, it shows you that we can perform alternative solution instead of the partial fraction that you performed previously. So this method is faster compared to the previous one. So we can see there are more than one way to solve the same problem here. In some problem, you have fx equal to some example like this, which cannot be further reduced by using the partial fraction. So you find the root for x, let's say x plus a, x plus b here. So for this case, you found your x, a and b to be complex number. So if you use the calculator, you will find the root x equal to -1 plus minus 20i. So your a and b is equal to -1 plus minus 20i. So we cannot form the linear factor for this case, therefore we cannot perform the partial fraction. So in this case, if you cannot further reduce this, simplify this by using the partial fraction, then we can use the completing the square method. So you have x squared, okay, plus 2x. So x plus 2x here divided by 2, you get 1 power of 2. So you have to minus with 1 here, plus 401. So with that, this one can be simplified into 400. So you get this result. And when you compare to the table, you will see that the denominator is similar to formula 10 and 11 here, where your a is equal to -1, omega is equal to 20. So when you have omega squared, it will be 400. So when you substitute a and omega inside this formula, you obtain exponential negative t sine 20t is equal to 20 over x plus 1 square and then plus 400. Next formula, you have exponential negative t cos 20t, okay, and here you have x plus 1 divided by x plus 1 square plus 400. So from formula 10, you have the inverse Laplace transform for this term, and then the result you will get this. And from formula 11, so inverse Laplace transform for this, you will get this answer. The question is, how can you find the constant in front here to be 3 and -7? How can we get this? So far, by referring the denominator, which is similar to the formula here, we can form these two terms. Next thing, we need to convert the denominator at the top to have the component s plus 1 and also 20. So you can see that 3x minus 137 can be written here, and to form the x plus 1, we replace the s to be s plus 1. So you have 3x plus 3. So 3x plus 3 you have to minus with 3 so that you get back the original formula. So with that, we obtain 3x plus 1. So the -3 here can be minus -137, give you -140. And lastly, you need to form 20 here. So with that, we can have 20 multiplied with 7. So this is our answer. Therefore, this term can be converted to this denominator where your 140 is equal to 7 multiplied with 20. So that you can have the constant 3 and -7 in front. So with that, you can get the final answer. Let's find the inverse Laplace transform for this fx. By referring to the denominator here, it has the same format with the formula 8 here. And you can see the omega is equal to pi. So your omega is pi. For this term, it has the same format with the formula 7, where you can see your a is equal to -2, so you have s plus 2 here. So your a is -2. By using equation 8, we can easily find the f equal to this, where your fx is equal to this. And by using the formula 7, your ft is equal to this, when your fx is this. So your f1x to be this. So in this problem, you are going to solve f1x multiplied with exponential -x. Second term, you have f1x exponential -2x. This is your f2x, and your third term will be f2x multiplied with exponential -3x. When you see that you multiply the exponential in the Laplace domain here by referring to the formula 17. So let's say this is fx, your Laplace domain. You multiply with exponential function. So when you convert to the time domain, you observe some time shift. So what is time shift? Time shift is where you have the t shift by a here. So t minus a is the time shift term. And previously we have discussed the u is indicating the unit step function. Let's focus solving the first term at the moment. So we hold on the second and third term. Refer to the denominator, so we can use the formula 8 to solve it, and we get the ft equal to this. So since you want to solve the f1x multiplied with the exponential -x, so by compare the formula, your a is 1 here, so you get the a equal to 1. So your time domain substitute a equal to 1. So these are the answer. So your f1 t minus 1 can be found from here. So since your ft is equal to sine pi t over pi, so when your t is equal to t minus 1, your t here also can be replaced by t minus 1. So this is your answer. So we can substitute inside here. Then you success to convert the fx to the ft here. So this is the answer for the first term. Next, let's solve the fx equal to the second term only. So in this case, your fx will be equal to the exponential negative 2x multiplied with the f1x. So this is your f1x previously. So we multiply exponential negative 2x, you will get this term. So we can use the formula 17 by using the same method. By comparing these two, you get the a equal to 2. So you have this a equal to 2. So substitute inside this formula, you get t minus 2 to be your time shift. So if you want to find the ft minus 2, same thing, substitute t minus 2 on the left hand side. So you get the sine pi and then t minus 2. So substitute this inside this formula, you're able to obtain this answer. So this is the answer for the second term. We have last term to be solved here. So we have the denominator s plus 2 squared. So we can use the formula 7 to solve this. So by solving the inversion for this Laplace transform, then we can get the f2t here. So by refer to the original problem, you found that f2x you need to multiply with exponential negative 3x. So by using the formula 17, so these are the problems we are going to solve. And then by referring to the a here, a is equal to 3. So you can substitute it inside the formula here. Then you get t minus 3 to be the time shift. This is the ft, so you can substitute t to be t minus 3. So on the left hand side, all the t is replaced by t minus 3. So after you substitute inside, you should be able to obtain this answer. And don't forget you need to multiply with the unit step function here. So you have to multiply with unit step ut minus 3. So this is your final answer. So for the first term, you get the ft equal to this. So this is the answer for the second term. And this is answer for the third term. And the total ft will be just the summation of these three answers. And you should write it in this final answer. In this example, you are going to find the inverse Laplace transform for ln 1 plus omega squared over x squared. And this ln term can be simplified into this, where your 1 is equal to x squared over x. So you have x squared plus omega squared at the top, and then dy can be equal to negative between the ln. If you check the table for the fx, there is no ln function here. So we can't perform the direct transformation for the ln function. But we know that when we integrate 1 over x, a polynomial function, you will get ln x. So if you differentiate the ln function, you will get back the 1 over x. So if we take the derivative or the differentiation, we can obtain the polynomial which can be transformed to the ft by using the table. So with that, we can refer to the formula 23, which involves the differentiation in Laplace domain. So if you have negative here, over here you have positive. So if Laplace domain you have positive, then you will get negative here. So with that, let's compute this term where you have the d over dx fx is equal to f prime x. Then we can substitute the fx inside here to obtain this term. So when we differentiate with respect to x, so x squared plus omega squared at the bottom, and you differentiate x squared, you get 2x at the top. Then for this term, you have negative 1 over x squared, which is this, and you differentiate the term inside, you get 2x at the top. So this is equal to Laplace transform of negative t ft based on this formula. So if we take the inversion of the fx, we will get the negative t ft. Move the negative t to the left hand side, you obtain this equation, and then take out the two constants, then you can form the constant 2 over negative t here. By using the table, you can find the ft for this term, which is cos omega t, and ft for this is 1. So with that, you obtain the answer. So when you perform inverse Laplace transform, you get this ft.